Hey guys, so this is day 11 of the Leetcode challenge, and we are looking at a question called diameter of a binary tree. Right, so we are given a tree and we need to compute the length of the diameter. The diameter of a binary tree is the length of the longest path between any two nodes of the tree. So it could be this, could be this, and it can be this. Like any two paths, it doesn't have to pass through the roots of the tree. If the path is something like this and something like this becomes the longest path, right? And actually the solution is available. So actually I want to go through the solution which they have posted and figure out how that solution really works, right? So this is the Python solution they have posted. So let's go through this solution. So what they are saying is let's calculate the depth of the node in a usual way, which means by doing the max depth of node on the left and the depth of the right node plus 1. Okay, and here they have defined a function depth. Okay, right, so this function gives basically the max depth from the node to any leaf in the subtree on this node as a root. Suppose this were to be our tree, okay, and I call depth on this node, right? So it will actually return me 1 2 3. So the depth of this node is 3. So actually they are defining the depth of a node in terms of the node in the longest path from this subtree, right? And how do they calculate that internally? So basically for any root, they take the depth of its left child, they take the depth of the right child, left and right child, and do just a max of it plus this one which is the root of the tree, right? So depth will become max of right, this depth, and plus one this node, plus one this node, right? So this is concise and clear, right? So forget about this line right now. Okay, so this is where they are calculating the depth, right? Okay, now what they are also saying is while we do this, a path through this node uses 1 plus depth of left plus depth of right node, right? Any path from this node, right, the longest path from this node in this subtree will actually use the depth of this node plus 1, which is this one, right, which is the root of the tree. So max path of a particular node can be depth of node dot left, depth of node dot right plus 1, right? So this is actually what they did here. So this is what exactly they did in this line, right? So they calculated the maximum path from this particular node here, and they are just storing it in a global variable called self.answer, right? So they have watching the tree, they are watching the tree, and for each node they are calculating the depths of its left and right children and calculating the max path from this node and just storing that as in a global variable and maxing and running a max function on that, right? Now this whole function of depth runs on the number of nodes. So if you calculate the max path, so the max path, so if it has 1 2 3 4 5 6, this nodes, there are equals to 6 nodes, right? So this will be our actually max path which self.answer will contain. Self.answer for this particular tree will contain 6, right? But we actually need to give out the edges. Edges can be nodes, number of nodes num minus 1, because for any two nodes you need one less edge to connect it. For two nodes we need only one edge. For three nodes we need two edges. So basically that is what they are doing here, self.answer minus 1. Now let's look at the time complexity here. So we visit every node once. That is true because we run depth from the start of the root here and then walk the tree each node at a time. Space complexity order n, the size of an implicit call stat during a depth first search. So this is also taken into account that when we do a recursion on this, which means calling depth on root and calling depth on node.left and node.right, we're implicitly putting our call functions on the memory stack here. So root goes here, then left goes here, then right goes here, and then basically actually left goes here, and then left goes here, and so on and so forth. Right? So this is how they are calculating the space complexity. I hope you like this video. Please subscribe to our channel, and we'll build more videos like this on the current LeetCode challenge and other LeetCode problems as well. Thanks for watching, guys. Again, like, subscribe, and comment. Thank you.